In this scene, we have a function named prefetchData. Its purpose is to download data from the server that will be needed for the next web page the user wants to visit. The function takes one parameter, nextRoute, which is a string representing the URL path of the upcoming route. Inside the function, we see a console log for demonstration purposes, but in a real-world scenario, you would perform an actual network request to your API endpoint, passing the nextRoute as a parameter, and then process the returned data, commonly in JSON format. Moving to the next scene, we introduce the handleRouteChange function. This function gets called whenever a route change is anticipated. It takes in nextRoute as an argument, which we then pass to our previously defined prefetchData function. The main goal here is to initiate the data loading process for the next route as soon as the user indicates they are about to navigate there, thus potentially reducing wait times for data loading after navigation. In this scene, we assign an event handler to the Windows on pop state event. This event is fired when the active history entry changes, such as when the user clicks the browser's back or forward buttons. The handler function extracts the path name from the event's target location, which represents the next route the user is navigating to. We then call handleRouteChange with this next route, ensuring that data needed for the next route is prefetched. In our final scene, we address scenarios where the user initiates navigation by clicking a link. This code snippet attaches a click event listener to every anchor element on the page. When an anchor is clicked, the event listener retrieves the value of the href attribute, which is the URL of the link's destination, and we again invoke the handleRouteChange function with this next route. This preemptive action allows us to prefetch data for the URL the user intends to visit, thus enhancing the user experience with faster page loads.